Yo. Do 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 do. Alright, hold on. Test, test. Alright, see if this audio goes through.
Okay. Now, but when the challenge arises, when one
Alright, audio goes through. I got chat open. Do do do. We need to finish chapter 5 today. Do 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 do. Thing is, I don't even know what slide I'm on. I'm here, I know that.
autonomous routing protocol domain, this can use distance vector also. Suppose, okay, so we can autonomous system. This is another autonomous system. This is another. This is another. And so on network. Okay, so basically we can say that the internet approach we so we can't store all destination in the routing table, and if we store this information, then the routing table will overflow, so it will not be impossible. So what is the option that we the internet is basically network of networks. Okay, so one network, for example this network, it is called autonomous system. This network, it is autonomous system. This network, it is called autonomous system. So one network, it is called a network that is within the single administrative control. For example, this is the regional ISP of PTCL, that it provides the connectivity to the access ISP in Pakistan. Okay, so this is in the control of PTCL. So this is called autonomous system. Okay, so normally we have in the internet we have autonomous systems, and these, what is autonomous system? A particular network, it is called autonomous system. A network that is within the control of one organization, one administrative control, that is called autonomous system. So basically we have different autonomous system in the internet is consist of networks. Networks means autonomous systems, and these autonomous systems, they are interconnected with each other. Okay, so basically the we have the internet is network of networks, so each network administration may want to control routing in its own network. Okay, so basically we can say that the internet approach, we use a word that is called autonomous system. So what is autonomous system? Basically autonomous, we aggregate routers into regions known as autonomous system or domains. Okay, so So if we have a region, for example, you can say that this is one autonomous system, this is another autonomous system, this is another autonomous system, this is another, and this is another, and so on. Okay, but there is another challenge or another very important distinct characteristic, and that characteristic is what? For example, we have three autonomous system like this one. This is one autonomous system number three. This is autonomous system number one. This is autonomous system two. This autonomous system two, it contains the routers or the host or whatsoever. The, this network structure is under the controller of autonomous system number two. This autonomous system number one, it controls this region, the host, the router, the switches, the server, all the things. This total network is under control of autonomous system number one, and this, and similarly for autonomous system number three. Now we have two types of routing. For example, 3C wants to send data to 3B. So there is a possibility that one system, a source node, is sending data to destination, and both source and destination, they are within single autonomous system. So this is called intra autonomous system routing. Okay, so this autonomous system, it can use link state routing protocol within its network. This autonomous system, it can use distance vector routing protocol in its domain. This can use distance vector also. Suppose, okay, so we can see that if we have different networks, different autonomous system, then each autonomous system is controlled of a single organization. So that organization can use any routing protocol that it wants. For example, autonomous system 3, it is using link state routing protocol. This autonomous system 1, it is using the distance vector. This is using distance vector. Okay. Now, but when the challenge arises, when autonomous system 1, autonomous system number 2, it want to send data to autonomous system number 3. So this data, autonomous system 2, it cannot send directly to autonomous system number 3. So it has to pass through autonomous system number 1. So when the data is moving from one autonomous system to another autonomous system, so we need the routing protocol. And this routing protocol, it can be called inter-autonomous system routing. So basically, in autonomous system, we have two types of routing protocol. One is called intra-autonomous system routing, that is used for communication between routers or among routers within autonomous system. And one is called inter-autonomous system routing, that is used to compute the routing or to compute the route from a source machine in one autonomous system to another autonomous system. This is called inter-autonomous system routing. Okay. So when we introduce the autonomous systems, when we divide the internet in the autonomous systems, so we have two types of routing. One is called intra-autonomous system routing. Intra-autonomous system routing, it is basically routing among hosts or routers in the same autonomous system, that is within the same network. So the all routers in autonomous system must run the same intra-domain routing protocol, intra-autonomous system routing protocol. For example, either autonomous system can use link state protocol or it can use distance vector routing protocol. Router in different autonomous system, it can run different intra-domain routing or intra-autonomous system routing protocol, as I have explained to you that this autonomous system 3, suppose it is using link state routing protocol. The autonomous system number 1, it is using distance vector. Autonomous system number 2 is also using distance vector. Okay. So when different autonomous systems, they are connected with each other, so you can see that this router 3B in autonomous system 3, it is connected to the all routers of the same domain. 3B is connected to 3C and 3A, and 3C and 3B, 3C and 3A, they both lies within the autonomous system number 3. So they are in the same domain. Okay, but this 3A, it is the router that is connected with the routers in autonomous system 3 as well as with autonomous system number 1. So a router that interconnects two autonomous system, that router is called gateway. That router is called gateway. So 3A is gateway, 1C is gateway, because it is connecting one autonomous system number 1 to autonomous system number 3. 1B is a gateway because it connects autonomous system number 1 and autonomous system number 2. 2A is gateway. Why? Because it connects autonomous system number 2 to autonomous system. So we can say that if a router connects two autonomous system, then that is called gateway router. It is a specialized router. It is called gateway. And that autonomous system which is not connecting with the more than two autonomous system, more than one autonomous system, that is called normal router. That is called normal router. So when we introduce autonomous system routing, when we introduce the autonomous system, that is the internet, when the internet is divided into autonomous system, then we will have inter-autonomous system routing and inter-autonomous routing. And second, that we may have gateway. Gateway router means these are the routers that are at the edge of its own autonomous system. That is, it has links to routers and other autonomous system. So gateway router is a router which is connected to more than one autonomous system, that connects two or more than two autonomous system. That is called gateway router. Okay. So I think this this topic is clear. It is normally at the edge because it connects one autonomous system with another autonomous system. So when we need inter-autonomous system routing, this is the routing that is used for the host or router within same autonomous system. When we want to move the data from one autonomous system to another autonomous system, then we need inter-autonomous system routing. So inter-autonomous system routing, it is the routing that is used among autonomous systems or among the domains. So basically this inter-autonomous system routing, it is basically performed by the gateway routers or the gateways. So inter-autonomous, because the gateway routers are the gateway, they connects the two or more than two autonomous systems. So therefore the inter-autonomous system routing, it will be running or it will be implemented on the gateways. So gateway perform inter-domain routing. So as well as the inter-domain, because the gateway is part of you can see that this gateway router, it is part of this autonomous system, so it will use inter-autonomous system routing, and it is also connecting with this autonomous system, so it is also using the inter-autonomous system routing. So on the gateway we use inter-autonomous system routing and inter-autonomous system routing, but on the non-gateway nodes only inter-autonomous system routing protocol is running. Okay, so I think this slide is clear now. Okay, now moving uh, 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 let's move ahead. So you can see that we have different autonomous systems. Okay, they are connected with each others. So forwarding table configured by both inter and autonomous intra and intra-autonomous system routing algorithm. I would like to discuss this slide. Before discussing this point, I would like to discuss how the routing is performed between two or more than two autonomous system. Then I think it will be much clearer. Okay. Now let's discuss another important characteristic. I think it will be clear to you. Now suppose that we assume that the gateway it maintains only inter autonomous system reachability. You can see that this is the gateway, this is the gateway 1B. It is connected with the autonomous system 2, so it will have the information that is connected with autonomous system 2. And this gateway also have the information that autonomous system is connected with autonomous system number 3. Okay. Similarly, that this gateway, it has information that it is connected to the autonomous system number 3 and as well as to autonomous system number 2. Okay. Let's suppose that the gateway, it maintains the inter autonomous system reachability. That only the gateway knows that how many autonomous system are reachable from here. Okay, you can see that this gateway, it knows that it is connected to autonomous system number 1 and it is further connected to autonomous system number 2. Okay, so if this information is, that is the inter autonomous system information, it is only maintained and the gateway. So suppose the router 3B in autonomous system number 3, this, it wants to send the datagram outside of outside. For example, this 3B, it wants to send a packet. It has received a packet from the host and it wants to forward that packet to 2B, for example, here. So we know that the inter autonomous, now it comes to know that it is, the packet is going to autonomous system number 2, but it doesn't know that where is autonomous system number 2, because this 3B, it only knows about intra autonomous system routing. In the inter autonomous system routing, it is present, its information is present in the gateway in the 3A. Okay, so in this case 3B only knows 3C and 3A, but it doesn't know about autonomous system number 2. So what should it do? So in this case, it knows that the 3A is the gateway. We have already discussed. The 3A is gateway. So if a node doesn't know about the destination, then the node forward the packet to default gateway. So in this case, the gateway is 3A, so the 3B will forward the packet to 3A. When the 3A receives, so it is a gateway, so it has the information that autonomous system 2 is reachable from autonomous system number 1. The autonomous system number, first the packet should go to autonomous system number 1 and then to autonomous system number 2. So now the gateway can forward the message to autonomous system number 2 through autonomous system number 1. Okay, so this is simple. That now we again I would like to emphasize that suppose we assume that only the gateway routers, it maintain the inter autonomous system reachability. So in this case it works fine. However, suppose this 1D, it want to send the data to 2C, to autonomous system number 2. Now 1D only knows about 1A, 1C, 1B. It doesn't know about autonomous system number 3 and autonomous system number 2, because this information is only maintained on the gateway. Now 1D wants to send data to autonomous system number 2, so 1D doesn't know that where is autonomous system number 2. So in this case it should forward to gateway, but here the gateway are 2, 1B and 1C. So whether the 1D should forward the data to 1C or to 1B or to both. So if the data is forwarded to 1C, then it is far away, but it is forwarded to 1B, then it is closer. Okay, so therefore we also assume that when the gateway they receives the inter autonomous system routing information, the gateway enhance this information, the autonomous system information, this autonomous reachability, this inter autonomous system reachability information to all the nodes in the autonomous system by using intra autonomous system routing, because this 1B is already communicating with these routers in for intra-autonomous system routing. So in this intra-autonomous system routing, for example, it is using link state routing protocol. It will also distribute the information of inter-autonomous system reachability. So you can see that 1D can receive the information that autonomous system when 1B announce autonomous system 2 and autonomous system 3 and its intra autonomous system routing protocol to 1D, 1C and 1A, then 1 and similarly 1C also announce the autonomous system reachability, inter autonomous system reachability information to its autonomous system routers within by using inter-autonomous system routing. Then 1D can come to know that autonomous system number 2 can be reachable from 1B and is from 1C. But 1B is closer. 1B is closer because so it will announce it will transmit the data to 1B. Okay. So therefore, I would like to emphasize that the forwarding table that is configured at each router, it is configured by two routing protocols. One is by inter-autonomous system routing protocol that is used within the autonomous system, and by inter-autonomous system routing protocol that is used by the gateway only. So the gateway router, it only use the inter-autonomous system routing as well as intra-autonomous system routing. But the non-gateway nodes, they only use the intra-autonomous system routing. The gateway nodes, they run both inter-autonomous system routing and intra-autonomous system routing. That is, they know about the routing between our two autonomous systems. Okay, and it also runs the intra-autonomous system routing protocol that is used for the reachability among the routers within autonomous system. Okay, but the gateway nodes, it also announce the inter-autonomous system routing information in the using inter-autonomous system routing to its all the routers in domain, so that we assume, so that when 1D wants to send data to an autonomous system and there are two gateway, then it can know that which one gateway is closer, which one gateway is closer to an autonomous system, so that can be so the packet can be forwarded to that router. Okay, so I think it is much clear. So forwarding table, it is configured by forwarding table in a router, it is configured by both inter-autonomous system and inter-autonomous system routing. Is for command the what is the inter-autonomous system task. Okay, suppose router 1A, but through so gateway protocol job of inter-autonomous system routing. Now intra-autonomous system routing, it is also known as interior gateway protocol or IGP. The most commonly intra-autonomous system routing protocol are RIP and OSPF. They are currently used. RIP is a distance vector routing protocol and OSPF is a link state routing protocol. We have discussed distance vector and link state in detail. We have discussed. And IGRP, it is a Cisco proprietary intra-autonomous system routing protocol. Okay.
Oh my god, this is so boring. Doesn't help that I'm so tired.
So,
I'm about to say rip to this whole stream. But no, I'm gonna try and pull through. Look at this. It's 3.5 hours worth of the rest of this chapter.
As we know that autonomous system, when we introduce autonomous system, so we have two types of routing protocol. One is called inter-autonomous system routing. That is the routing algorithm that is used by the router to reach from one router to another router within autonomous system. So for this purpose, in inter-autonomous routing protocol can be OSPF, that is used in link state routing protocol, or RIP, which is the distance vector routing based protocol. Okay, or it can be the interior gateway protocol. So we have already discussed the RIP, the distance vector and OSPF in detail. So I
Most common RIP, routing information protocol, and open shortest path first. EIGRP, EIGRP, EIGRP.
will not go into its detail, but we can just have an overview. Okay. So OSPF, it is open shortest path first algorithm. It is open, publicly available. Its RFC is available. Its complete implementation detail is available. So it uses link state routing algorithm. So you should know that what does link state routing protocol means. Okay. So we have already discussed it. The router floods OSPF link state advertisement to all other routers in entire network. Okay, in the entire autonomous system, and this information they are carried out in the IP directly in the, okay, over IP. Okay. Another is ISI routing protocol. Also, it is also identical to OSPF. Okay. So this we have already discussed in the link state routing protocol. So OSPF is following the link state routing protocol options operation. Okay. Moreover, the SPF also have some advanced features, and these features include security, multiple paths, etc. Okay. Now we are
Hmm.
going to discuss the inter-autonomous system routing protocol, and for this purpose we have the BGP. This BGP, it is the inter-autonomous system routing protocol. As we know that up to now we have discussed that when autonomous system is introduced, okay, so we have two types of routing protocol. One is called intra-autonomous system routing algorithm. So this can be link state or distance vector. So its RFC is OSPF, that is currently used for, okay, RIP. Okay. uh, and now in the next type of routing protocol, another is autonomous system routing. So we are going to discuss this inter autonomous system routing algorithm in detail in the next video. Okay. So we will discuss this that when we introduce autonomous systems. So we have two types of routing protocol. One is called intra autonomous system routing. So that is used by the routers to within autonomous system. So it can be used, the distance vector or link state routing protocol can be used. And another type of routing protocol, it is called inter-autonomous system routing. It is used for the reachability between autonomous system or among the autonomous system. Okay, so now we are going to discuss this inter-autonomous system routing. So the BGP is one of the routing protocol that is used for inter-autonomous system routing. BGP is called Border Gateway Protocol. Okay, the BGP it provides each autonomous system a means number one to obtain subnet reachability information from neighboring autonomous system. So this is called eBGP. For example, you can see in this example. For example, autonomous system 3 can reach to autonomous to network X. So this information will be announced to 2C. So the gateway, it is announcing this information to another gateway, and this is done by using the eBGP protocol, external BGP protocol. And when 2C receives this information, that it can reach to autonomous system number 3, and then it can reach to X through autonomous. So when the 2C receives the information, that 2C can reach to network X through autonomous system number 3. This information is advertised to all the routers in its domain by using IBGP protocol.
Internal,
Okay,
external.
so the eBGP protocol is used to obtain the subnet reachability information from neighboring autonomous system, and IBGP is used that this information that is obtained of the neighboring autonomous system, it is propagated to all the routers in the autonomous system. So IBGP is used to propagate the reachability information to all autonomous system internal routers. Okay. Now, one particular difference between inter-autonomous system routing protocol and inter-autonomous system routing protocol is that the best path or the good path is the one which is based on the policy, based on the policy. Okay, that is in the link state routing protocol or in the distance vector routing protocol. So we were assuming that the good path or the best path is the one which has the least cost, the least distance, or which has the least traffic, or which has least congested, or which has the more bandwidth. But here the good path is one which can be reachable and which is allowed as per policy. For example, the Pakistan and India, they have political issues. So if the India wants to transfer the goods to Afghanistan through Pakistan, so Pakistan doesn't allow it. Okay, so this information is advertised. So we will discuss it through an example. For example, I would like that this autonomous system 1, it can reach to autonomous system number 3 through autonomous system number 2 and through autonomous system number 4 and 5. Okay, but here the autonomous system 2 has a policy that it doesn't route the traffic from autonomous system 1 to autonomous system number 2. It doesn't want to transit the traffic from here to here. Okay, so if it doesn't want, so it will not advertise. The autonomous system 2 will not advertise to autonomous system number 1, that is through this gateway, that I can reach to autonomous system number 2. So if autonomous system does not advertise the autonomous system 3 reachability to 1C, then 1C will not come to know that it can reach, the 1C can reach autonomous system number 3 through autonomous system number 2. Okay, so suppose these two autonomous system, they allow their traffic, the autonomous system 1 traffic, to reach to autonomous system number 3. So then the autonomous system 1 will use this route. Okay, so the route is not selected that is the that is at the that is the closest, but that route is selected which is allowed as per policy. Okay, so there are two session present, so I would like to explain it. For example, autonomous system number 3, you can see this autonomous 3A gateway, it advertise that to this 2C autonomous system 3X. What does it mean? That network X can be reached through autonomous system number 3. Okay, so it means that when this information is advertised, when autonomous system number 3 gateway router 3A, when 3A router, it advertise the path autonomous system number 3X to autonomous system 2 gateway router 2C. When this 3A it advertise this autonomous system 3 X information to TC, then what does it mean? It means that autonomous system 3 is promising to autonomous system number 2 that autonomous system number 3 will forward datagram toward X. So if autonomous system 3 receives the datagram for network X, then autonomous system 3 will deliver this datagram to network X. Okay, so this 3A router gateway, it advertised this autonomous system 3X information to 2C using eBGP. Which one? eBGP. eBGP means external Birthway Gateway Protocol. eBGP. This one. This one. eBGP is used. eBGP means exterior Birthway Gateway Protocol. Okay, and IBGP means internal BGP protocol. Okay, so when this 2C router gateway, it receives this information, so 2C advertise this information to all its neighbors, to all its routers, not only neighbors, to all its router through IBGP. Okay, so through IBGP it is allowed. So basically a path attribute, BGP, it contains two attributes. One is autonomous system number path, one is next hop. Okay, what does it mean? So we will discuss it in through an example. So suppose this 2C receives this information from 3A. Okay, then 2C will advertise this information to all routers. So all routers, for example 2D, will come to know that it can reach, the 2D can reach to X through autonomous system, through 2C, through autonomous system number 3. Okay, so but if 2D wants to transmit the data to X, so it has first to transmit the data to 2C. This is the next hop. So 2D will forward the data to 2C, then 2C will forward data to autonomous system number 3, and then autonomous system 3 will deliver this data to X. So the next hop for 2D is 2C. Okay, so there are two attributes. One is the next hop, that if 2D wants to transmit the data to X, so which router should be selected as a next hop? So this is called next hop, TC. Okay, and another thing, important attribute is that of autonomous system path. Okay, so what does it mean? That if 2D wants to reach to X, so it has to pass through autonomous system number 3. It has to pass to autonomous system number 3. Okay, so the when 2C receives this information, so this information is passed to all the routers, internal routers. So all 2D, 2A, 2B, they come to know that they can reach through network X through autonomous system 3. Okay, similarly when 2A receives this information, the 2A pass this information to 1C. So you can see that 1C will receive that if 1C wants to transmit data to X, then this data has to be passed through autonomous system number 2, autonomous system number 3. So this is the autonomous system path. So 1C can reach to X after passing through autonomous system 2, then to autonomous system number 3, then it can reach to X. So if 1C wants to transmit data, then it has to first go to next hop 2A. This is the next hop. Okay, so when 1C receives this information, 1C will also announce this information to all its router within the network by using IBGP protocol session. Okay, suppose that there are multiple paths, there can be multiple paths. For example, this is one path and this is another path. Okay, so in this case you can see that if the path is advertised like this way, okay, this is one path, and another path is also advertised through this path. So 1C, it can reach to network X either through this path or through this path. Okay, so in this path, the autonomous system path, it consists of autonomous system number 3 and then network X. And this path, it consists of autonomous system number 2, autonomous system number 3 and network X. Okay, and the next hop for this path is, next hop is 3A, and for this path the next hop is 2A. So if the data is to be forwarded on this path, then the data has to be first forwarded to this as the next hop. This is the next hop, 2A is the next hop, and on this path the next hop is 3A. Okay, so if we have multiple paths, then which path is selected? Okay, so the path is selected based on the different features. We will discuss it. Okay, so basically this uh, messages that are exchanged between the routers are when the gateway receives the advertisement from the autonomous system. This information is advertised to the rest of the routers. So these so the BGP actually have different types of messages. So the BGP messages, they can be of four types: open, update, keep alive, or notification. The open message, it is used to open the TCP connection to remote BGP router and authenticate the sending BGP. The update, this message is used to advertise new path or to withdraw the old path. The keep alive message, it is used to keep connection alive in the absence of updates. And notification is used for reporting the error in the previous messages. Okay. So when when a router, it has multiple paths, for example in this case, okay, so how the forwarding entry is performed. Okay, so first of all, we had noted that the BGP protocol, it is used, the BGP protocol, the BGP protocol is used to provide the reachability information, to provide the autonomous system reachability information. Okay, for example, the this gateway, it announces the reachability information of network X to this 2C. Then 2C announce this information to all its routers. Then this gateway announce this information to 1C, and then 1C advertise it to all the nodes. Similarly, the 3A also advertise this information to the 1C directly. Then 1C,
I forgot what the OSPF means. So like one shortest path first. Open shortest path.
also advertise this information to all the nodes. Okay, so this, for this purpose, this is the working of inter autonomous system routing, the BGP. So its working is finished. So the BGP, or the inter autonomous system routing protocol, it provides the reachability information of autonomous system, it provides the reachability information of autonomous systems. Okay, this is done. Now we have another protocol that is called inter-autonomous system routing, that is used for reachability within the single autonomous system. For this purpose, we can use intra-autonomous system routing. So this intra-autonomous system routing, it can be OSPF, like it can be link state routing protocol, it can be distance vector routing protocol. Okay. So this OSPF, or this intra-autonomous system routing protocol, link state or distance vector routing protocol, it basically builds the forwarding table to reach from one router to another router within this autonomous system, within a single autonomous system. Okay, for example, you can see that OSPF, or link state routing protocol, or distance vector routing protocol, that is any intra autonomous system routing protocol is used to build up this table. That is, if 1D wants to reach to 1C, okay, or to reach to X, destination X, so it can reach to destination X through interface number 1, through interface number 1. So 1D, it can reach to X because 1C has advertised it to 1D. Okay, that it can reach to X from through 1C. Okay, so what is the distance from 1D to 1C? Okay, so we can see that if you want to reach, if 1D wants to reach to X, so it can reach to X through 1C, and 1C is from 1D, we can reach to 1C by using the link number 1. Okay, so this information will be stored here. Similarly, you can see that 1A, it can reach to network X through 1C, through 1C. So if 1A want to reach to 1C, then it can send the it can use this link. This link is the best part. Okay. Now, if we have multiple paths, like as we have discussed in the
When when I use these two.
previous example, like here, okay, like here we have multiple paths. Either this path should be used, either this path should be used. Okay, so in case of multiple paths to reach to a network X between inter-autonomous system, okay, keep in mind that we have different okay. So how if a node want to reach to outside autonomous system, for example, this node 1D, it wants to reach to autonomous system number this, so either it should use this path or this path. So which path should be used? If 1C wants to send data to network X, so either it should go to this path or through this path. So which path is selected? So in case of multiple paths, so the a path is selected based on these criteria. Local preference value, attribute, or policy decision can be used, or shortest autonomous system path. That is, that path should be used through which least number of autonomous system are passed. For example, you can see that in this example, okay, in this example, if in this shortest autonomous system path, that is, that path should be used through which least multiple to network X. So either it should go to this path or through this path. So which path is selected? So in case of multiple paths, so the path is selected based on these criteria. Local preference value, attribute, or policy decision can be used, or shortest autonomous system path. That is, that path should be used through which least number of autonomous system are passed. For example, you can see that in this example, okay, in this example, if in this example, if this path is followed, then it passes through one autonomous system. If this path is followed, then it passes through two autonomous system number 2 and autonomous system number 3. So the path through which least number of autonomous system are traversed, least number of autonomous system are traversed, the path that contain lower number of autonomous systems, that path is selected as a best path. Okay, for example, in this case, okay, or we can also select a path that is closest next closest stop routing. Okay, what does it mean? So let me explain it. You can see that, for example, uh, the 3A, it advertise this routing, this information to 2C. Then 2C advertise this information to all the nodes in the autonomous system. Similarly, the 3A advertise this reachability information to 1C, and 1C also advertise it to 2A. And then 2A advertise this information to all the nodes. So if 2D, in this case the 2D receives two paths to X. 2D receives two paths toward X. One is this path from 2C, and one is this path. Okay, so which path should be selected? There are multiple paths, two paths, this path and this path. So if the criteria of shortest autonomous system path is used, shortest autonomous system path, so what does it mean? Okay, so this path it contains one autonomous system, and this path it contains two autonomous system. So which one has minimum number of autonomous system? So this one has a minimum autonomous system, so this path will be followed. Okay, but if the criteria is used next hop router, closest next hop router, okay, then what does it mean? You can see that if 2D wants to use this path, then the next hop is 2C, and the 2C is the 2C it is at the distance of 263. If this path is used, then this path has the next hop 2A, and 2A is at the distance of 201. Okay, so which one is less cost, 201 or 263? So 201 is less, so this one will be selected, that is the path on which the next hop is closest. This next hop is at distance of 201, and this next hop is it is at the distance of 263. So this one is closest, so this path will be followed. Okay, so in case of multiple paths, so either we can use the autonomous system path length, that path will be selected which has the least number of autonomous system. For example, in this case this one will be selected, or that path will be selected which has the next hop closest. So here the next hop is 2C, and this is at the distance 263, and here the next hop is 2A, and this is at the distance of 201. So this is closest, so this will be selected. Okay, so this can lead to hot potato problem. Why? Because you can see that if this path is selected, this path is selected, then this is longer path. Okay, this is the longer path. Okay, now we have discussed that we can also use the policy. Policy means that suppose that we have network providers A, B, C. A connects network X. X is connected to provider B and C. Okay, so B and C both are connected to network X, and Y is connected to through providers.
Yeah, he took that out, didn't he?
If
Oh,
domain, then the path to C, so C cannot use this path. Okay, because it doesn't want. Okay, similarly, the end-autonomous system, the admin wants to control over how its traffic should be routed. So if want to allow the traffic to be passed, then it will advertise the route to other autonomous system. Otherwise, it will not advertise. But inter-autonomous system routing, it is within single domain. So if it is within single domain, then there is no policy decision needed. Okay, the policy decision between enter autonomous system, like the policy is to be discussed or to be consider between two countries, not within the single country. Okay, so this the hierarchical approach, this autonomous system, it did this called hierarchical routing. So it saves the table. How it saves the table? You can note in this example. Okay, that in this example you can note this. For example, this autonomous system, this network X, it has 1000 routers, 1000 IP addresses, but these 1000 IP addresses, they will be represented by a single entry, autonomous system number 3. So if we have 1000 entries here, then its table size will be higher, will be very large. But these 1000 entry, they can be replaced by just one entry, autonomous system number 3. Okay, so this reduce the traffic, the table size. Okay, and it improves the performance. Okay, so hierarchical routing table, it saves the table size and reduce the updated traffic. Okay, so up to now we have discussed the intra.
Oh my god.
Continue chapter number 5, network layer, the
Oh, I
control
just have 2
plane.
dislikes. What?
So in last class we had discussed autonomous systems, and then we also discuss how what how intra autonomous system routing. We are going. We have two types of network architecture. One is called per router control plane, and another is called software defined networking. Okay, currently that is means okay, and the control hardware, the implement is not open source implemented. They are not open source.
OSPF is it's not called one. What's it called? I don't know, something shortest path first.
Implemented. So different middle box for different network layer functions. For example, if you want to use firewall, so we have
Open
different
shortest path.
implementation, load balancing, net, etc. So all this be in there. A routing algorithm, it is present in each and every router. Individual routing algorithm, this has this is the to up because the data when the network this SDN data model 1 by it so it of HP router. However, the Cisco implement OSPF from using their own coding, their own logic, and own logic in their routers. They are called Cisco the per router. What does it do? Or how it is implemented? The advantages. Okay, okay. So why a logical centralized control plane? What are its advantages? Okay,
Finally got,
so
what does
some
it
of
say? Finally got over the huge hurdle in my RPG program. Let's go. Hey, that's what's up. I'm studying for this damn final. Thing is, I have to watch these videos because I don't know. It's easier for me to listen when I'm caring about listening. Because during class, it's just my professor's so boring. I just can't can't pay attention to him. And he goes too fast too, so I can't keep up. No, it's okay. You're good. Yeah, I got my exam schedule here. So I'm glad that I got Tuesday off. Tuesday, study day. And right now I'm studying for the computer networks because I don't know anything really from this chapter for this exam. So I'm getting a head start on this. I studied a bit yesterday, doing some more today. And then tomorrow I gotta start studying for this because he's gonna post the study guide tomorrow afternoon or something, so that's why I didn't start with this class. This gonna be easy. This one's probably gonna be easy, but I need to look over my notes. But I'm mainly gonna be this one I really need to study for. It's gonna be easy, but I need to go over my notes. And then this one I just need to do a bit each day. But that's done.
Of the advantages we have discussed, that if we have centralized control plane, then these
Architecture, like the computer architecture, yeah. Oh, whoops, that's not my notes. That's a calculator. Yeah, computer architecture, artificial intelligence, introduction to Python, which was an elective I think I picked, and then computer networks. Learned about pipelining in my computer organization class. Uh, is that the same as 4 and 6 cycle pipelines? Where you went over, let me see here. I don't know about those, but we recently went over some other pipelining stuff. It's gonna be easy, but the issue is I need to know how to draw these things, and that's the thing that I'm just like, oh, I need to remember how to draw them. So a lot of the stuff is like the memory stuff. Issue is it's 105 slides. Advanced computer organization. Is it like after this class? Like an improved version of it? The next level class? Cache memory, direct mapped cache. Because earlier in this semester we did assembly language. Uh, yeah, it's only this chapter, whereas the other exams I believe have just been 2 chapters. Let me make sure. So I'm not stressing too much about this exam. Let me see, what did he say? Yeah, there's a bit from where did he put? From chapter 4, but so I just need to study this stuff, but it should be fine. Little and big Indian, yeah. But there's like I gotta down like there's half these like chapter 5 I don't actually need to know. So I'm probably gonna download the PowerPoint and just delete the ones that I don't need to know because it's or the ones that are yeah, because it looks like I only need to know about 60 slides here, and then same thing here. It's only then there's some other stuff, but I need to know how to draw uh, one of these things. I don't know. His study guide usually helps a lot, so that's why I'm waiting for him to post it. Like he goes more into depth of what we need to know, and it usually helps. On my last exam, I got a 93, and I have no idea because wait, that's the what class is that? Yeah, I somehow got a 93 on my last exam for here, so I have no idea how I managed that. But yeah, I want to try and keep it A in this class. And he grades his exams pretty well, so I just had to do what I did keep doing for my studying for that class. Though for this class, I gotta make sure I pass. My grade in this class is gonna be it says 70, but it's actually a 72 because he drops the lowest quiz grade. And then he has to grade this other stuff, but yeah, he separates the two. It's basically just two exams, but they're as midterms. In the first one, I got a 0 because I got caught cheating, which it's whatever. But second one, I got 72. That's the one that I studied for like a week and a half for. And if I could get like a 72 or something, or like I don't know yet, but I just need to pass this class. It's the oh my god, it's the class I care least about. So annoying. I have zero interest in this class at all. It's just it's because there's no programming. It's just for to me it makes no sense why this is a required course for computer science. Literally none of the other courses follow this class. I'm not on the verge of failing. A 60% is passing. But I need to make sure I do somewhat good on the somewhat good on this final to maintain above a 60 or I want to try and maintain a 70, a C, but if I can maintain a 60 then it's whatever. But it makes this course does not follow any of the courses, which is makes no sense because my they made my I need a C to get credit, and right now I have a D. That's sad. They made my AI course. It is a requirement for uh my graduation requirements for this course, but they made this course not a requirement uh anymore. This course is gonna be an elective, which it's unfortunate because this course actually it actually is good. This course actually is good. Teaches you stuff, and computer networks, on the other hand, does not teach me anything. I mean, sure, I've learned some stuff, but do I actually care? No. And then my other course, senior design, I'm done with that class. I hated that class. Python, easy. Uh, yeah. Then next semester I have 4 classes, and then I graduate. 4 more classes. Oh my god. So tired with school, especially this semester. This semester has been hell and back, literally. It's also because I've been doing my internship, so it's hard for me to focus, especially since I like my internship more than I like school, so I'd rather be doing that, but like right now, if I wasn't studying, I'd probably be working on work stuff because there's some stuff that I need to get done, but I'm only working part time, but I don't know. Alright, I gotta get back to this.
Problem will be addressed. First, this in this SDN, this problem will never arise. This problem will never arise. Why? Because if there is a centralized control plane that computes the path for x, y, z, then this problem will never happen.
Good luck on your exams. Hey, thank you, appreciate it.
Loop. Similarly, if there is a centralized controller that computes the path for A, B, C, then this oscillation problem will never occur. Similarly, if the control plane is implemented in software, then we can do modification. If it is available open source, so we can check the coding and we can check the coding for error, whether there
Why does he say that? Check, check.
is an error in the code or not. Okay, and second thing, they have that
Wait,
there
what the
is
hell?
problem will never there is a then we or not. So it can working with management
Alright, here
logically centralized control plane. Okay, so it provides easier network management. Easier network management. Why? Because in the per router architecture, in the per router architecture, okay, let's see it. In the per router architecture, the control plane is present in each and every router. So if one wants to change or to configure the control plane, so one has to configure or change the control plane of each and every router. So if there are 10,000 routers, so one has to change the control plane configuration in 10,000 routers. So it is difficult to manage, but in SDN it is much easy. How it is easy? Because if one wants to change or one wants to change the configuration of control plane, so it has to be changed only here at controller, because the control plane is here at a single point and it will be implemented each and everywhere. So you don't need to, so if there are 10,000 routers, but you have to change only at a single point at the controller. Why? Because the control plane is present here, centralized. Okay, so the manageability is much easy. Okay, so it provides easier network management. It avoids router misconfiguration. Why? Because I told you that in the per router architecture, so the control plane is present in each and every routers. So if there are 10,000 routers and one wants to change the configuration of control plane, then one has to change the control plane of each and every router. So it to detect error, there are chances of error. But in SDN, we have to change the control plane configuration only at centralized point, at single point. So the chances of error are much less, and it provides greater flexibility of traffic flows. We will discuss this point through an example in the upcoming slides. Okay. Second, the O the in NSDN we use table based forwarding, and table based forwarding, it has more generalized. Okay, so let me explain it through an example. So if you know it about, for example, this, okay, this was the pattern, so you can use, but in the per router architecture we have only destination IP based forwarding, but here the we can use switch port, we can use make source address, make destination in this, ethernet type, we can use VLAN ID, IP source, IP destination, protocol, TCP source port, TCP destination port, etc. So there are so it the open flow it allows, and this open flow table, it has greater flexibility. We can use any of these combination to define a flow, to define an entry in the forwarding table, because you can see here the forwarding entry is defined based on IP source and IP destination. Okay, so the same source and the same destination, they have two different entries. Why? Because based on the IP source address. Okay, so it provides much flexibility, so we will discuss it in through in examples. Okay, and these the control plane basically it programs the data plane. Basically you can see that the control plane it basically built up this forwarding table. Okay, so it means that the control plane, the controller, it basically control how this router should work. Okay, so the programming of the hardware, the data plane, these are just dump devices, dump devices. Okay, and these how they should work, so they should work as per the direction, as per the instruction of controller. Okay, so this controller it is actually programming the data plane, that how the data plane should work. So it is basically programmed by the controller. Okay, so we have a centralized programming. Okay, only the controller has the centralized controller, it has to decide that which switch should forward the flow to which switch. Okay, and it is easier because managing from single point of view it is much easy, as if in the per router architecture, if there are 10,000 routers, so we have to do configuration in 10,000 routers, so it is much difficult. So in the SDN, the controller computes the table centrally, that is, and then distribute it. What does it mean? Okay, you can see that in SDN, the control plane is centralized in the remote controller. So this control plane it computes the forwarding table, the route for each router, and then that forwarding table is installed in the each router. Okay, so you can see that distributed programming it is more difficult. So we have discussed that the the per router architecture it is distributed in nature. It is the per router architecture it is distributed in nature. Okay, what does it mean? That in each router we have control plane, so it is difficult to manage. It is so if there are 10,000 routers, so there in each router we have control plane, each router we have routing algorithm. So it is so managing 10,000 control planes, it is much difficult as compared to managing a centralized control plane. Okay, like for okay, so that's why it is used. Second, another very important and interesting thing that I have told you, that it is the control plane is implemented in software. Okay, the control plane it is implemented in software. So you can, if you want to change the control plane, so you can just install the new software. Okay, so you don't need to replace the routers. Okay, but in the per router architecture I told you that this control plane and data plane they are implemented in hardware, so you cannot change it. Okay, in the per router architecture, and the SDN, the control plane is implemented in centralized controller, and this is implemented in software. And another important thing, that the coding is freely open. It is open, so one can do modification even in the coding, even in the coding, and one can also see the coding, that whether there is error in the coding or not. But in the per router architecture, I have told you that it is closed. The implementation, the coding of the control plane here in the router, it is not open. So one cannot see its coding. Okay, one cannot examine its coding for errors. Okay. So this is another. So the SDN it provides open source. non-proprietary implementation of control plane. So one can note that it will reduce the cost of the networking as well. Okay, the cost of networking as well. Okay, so the in the SDN, the control plane is not only implemented in software, but the control plane is also
Oh my god. There's like so much. Is it why it's easier to. It's difficult to distribute, easier to. Uh, con- the data table routings are faster, something like that. Than centralized programming easier. Distributed more difficult. Easier network management. Easier network management. Easier network management. Centralized is easier. Distributed is difficult. Uh, what else? What else? What else? Table-based forwarding. Open implementation, non-proprietary. Open implementation.
open source available.
Thing is, I'm gonna be watching these videos yet again this weekend.
Open source means that one can see the coding, one can modify it,
Not even this weekend. Half of this weekend.
and one can install its own application easily. Okay, so it will reduce the cost as well. The cost as well. Okay, so that's why many like Cisco, it was for router. They proposed the first they had open source, open flow based switches that were supporting the open source controller, but now they have their own controller which is called RNA. Okay, and that controller is proprietary. Okay, so therefore the vendors, they are some the advantage of uh, we have structure and the hardware application. If the technical problem, the hardware, okay, I specialist. We are going to discuss some more limitation of per router architectures. Okay, so suppose we call this problem traffic engineering P1, problem number 1. To change the weights of, okay, it is much open is central to define the forwarding. Okay, so for this problem, particular problem, for this particular problem, if to address an SDN, okay, so the first thing is that if you want to implement it, okay, so we have to do changes in the control plane, and much easy without changing the control plane. Okay, so this is the first advantage of SDN. The second advantage of SDN is that the data plane and control plane, they are separated. The data plane is left in the switches, and control plane is implemented centralizedly in a remote server, and this remote server is called controller. Okay, and this centralized control plane or centralized controller, it computes the path for each and every routers. Okay, so this is the another limitations. So it means that if we want to change the control plane, then we don't need to change the hardware, we don't need to change the data plane, we don't need to change the routers. So the routers remain the same, and we can change the control plane only at controller. And there are two more additional advantages, because this remote control plane, it is implemented in software, so we can just install the new software. And moreover, it is open source, open available, so the coding even it is also available open source. Okay, so the control plane functionality, it is external to data plane, so we can change the control plane without changing the data plane, when we can change the data plane without changing the control plane. Okay, and fourth, that this control plane that is implemented. It also provides
The fuck?
the somehow the abstraction. What does it mean? For example, I would like to explain it through an example. I think it will be much clearer.
Alright, I'm gonna just go through what we looked at today. Let me refresh this page. Alright, let's go through this. Open. Shortest path first. This border gateway protocol. I was gonna say patrol. Controllers, open flow, ODL, I don't. Forwarding, routing, control line is forwarding. Yeah, this, I see this picture 500 times here. Routing, I know this stuff. Wait a second, decentralize. Global, all routers have complete topology. Iterative process, computation, exchange info with neighbors. So this is like distance vector algorithms. Okay, yeah, that makes sense. But decentralized would also be, is it SDN? No, it's not. It's only exchange info with neighbors. Address initially only know link cost to attach neighbors. That'd be intra, whatever it's called. Yeah, intra routing, I think. See, I can do the link state easily. This other one though, this other one kinda stupid. U to V, Y to Z. Wait, no, that's V. Is it V to Z? Because that'd be 2, 3, 5. U to X, which is 1. X to z, which is 3, 5 to 3, u to w, w to z. Each node sends its own distance vector estimate. Isn't distance vector better because it's easier to update? Wait, recompute, and notify. I don't get this part at all. Like, why does the 8 go down here and then back up here? What? This I understand. This is fucking hell. This better be a 20-point question if he asks. Cause D of A to wait, D to C to A infinity, D to E of A is infinity. D A of A is 8. I'm gonna have to ask him that. I'm gonna have to try these interactive problems for tomorrow. Routing more scalable, thus ideal. Scale. Scalable routing is this. Enter autonomous systems, intra-autonomous systems. Inter-domain routing. That's basically all this is. Let me just ask. I mean, this all makes sense. Oh, I need to remember this. Most common intra is rip. dv. What is that? Distance vector. Link state routing. Okay. The border patrol. The Office of Admissions. Hold on. There is an open-minded question as well, similar to these two assignments. Alright. Isn't one of uh, isn't one of them based off of um yeah, here, policy, that's what I was thinking. Prefix, destination being advertised. Policy-based routing. Never route through ASY. Autonomous state Y. How does it know which one to choose from? Open, update, keep alive for notification. Intra AS, enter. Well, intra, yeah, there's one. Yeah, that makes sense. That makes sense actually. Whereas enter, it could go to different ones like this could go here, that could go there. But enter here, it goes around everything. Enter, wait, enter, policy determines over performance. Now that's a question. Yeah. Then I sort of went over some of this shit. Control plane separation, control plane data plane. These are open source control plane functions. These are easier to change. Programmable control applications. Yeah, I didn't go over that other stuff there, but I do think saves table size, reduce update traffic. Intra focuses on performance. Enter. Choose local gateway that has intra-domain cost. 2D chooses two-way, but that's hot potato routing. As path, where's... Oh wait, I guess... What the heck is this? Hold on. I'm be honest, I'm done. How do I end this shit? I'll end this shit right here. What was that? How long was that?